5G Enable Industrial IoT, a transformation towards smart factories by Faculty of Engineering and Built Environment of Masa University. My name is Lee Ying Long, and I am an electrical and electronic engineering degree student in Masa University, and I will be serving as your moderator today. Today, we will be having a presentation from Associate Professor Dr. Abdul Rahim Sadiq Bacha. Professor Sadiq obtained his PhD from Multimedia University in Cyberjaya, Malaysia. He received Masters of Engineering in Power Electronics and Drive Engineering from Bharathidasan University in India and Bachelor of Engineering degree in Electronics and Communication Engineering from Madurai Kamaraj University in India. Currently, he is working as an associate professor in the Faculty of Engineering and Built Environment at Masa University. He has more than 30 years of teaching experience at a master's and bachelor's degree level in electrical, electronics, and communication engineering. He is also a chartered engineer from UK Engineering Council, a graduate member in Board of Engineering Malaysia, and members of various professional bodies. He is a certified train-the-trainer and can provide training on 5G wireless communication, Internet of Things, and artificial intelligence. He has served as a keynote speaker, reviewer for peer-reviewed journals, and chairman in international conferences. Without further ado, I would like to welcome Professor Sadiq, who will be speaking to us of 5G-enabled industrial IoT, a transformation towards smart factories. All right, Professor Sadiq, the floor is yours.
Assalamualaikum and good morning to everyone. First of all, I would like to thank Mr. Lee for his nice introduction about me. Today's topic is 5G based industrial IoT. Yes, it's a digital transformation. So this webinar will be useful for engineers, scientists, and industry peoples to understand about a smart industry or smart manufacturing. So let me start with my slides. Okay, 5G based industrial IoT. Using this technology, we are transforming towards smart factories. Basically, digital transformation creates new possibilities for organization in innovative products, services with new ways of working. Especially industrial transformation or digital transformation in manufacturing is a process and enhances its process, products, and workforce with digital technology. This is, we can call it as digital transformation in manufacturing. Basically, we are enhancing the services, products, and workforce. This is our ultimate aim. So today's my webinar covers Industrial 4.0, a 5G wireless network, 5G industrial IoT, and some use cases, examples. First, what is Industry 4.0? Basically, it focuses on intelligence machine-to-machine communication, which is faster and with a smarter network. This we can call it as Industry 4.0. So basically now we are in Industry 4.0 with the 5G technology. So the 5G technology takes the industrial automation to the next level by reconfiguring the factories using mobile robots and AGV and inherent security and maintenance cost is lower. This is the advantages of 5G in industries. So Industry 4.0 is a fourth industrial revolutions. So automation and data exchange in manufacturing technologies is possible with Industry 4.0. What are the components of an Industry 1.0? It consists of cyber physical systems, IoT, cloud computing, and cognitive computing together with our latest 5G. So basically, it focuses on intelligent machine to machine communication, as I mentioned earlier. So it shifts our hierarchical automation model to automation in a decentralized network. So it meaning to say that we have every devices used in the industry have unique IP addresses and they are connected through industrial Ethernet protocol. This is we are enabling Industry 4. IoT through Industry 4.0. So we are shifting now. So what is the 5G digital transformation? So in there are two components: digitized mobile communication and another one human machine interface. Actually, here when you transform the real industry to the cloud environment, we are using 5G technology. Basically, here there are many advantages where we are using 5G technology. So basically, industrial automation comprises of 5G technology, Internet of Things, IoT, and as well as our smart manufacturing. So basically, first let me explain what is 5G, fifth generation communication, 5G, and what are its advantages. Actually, its frequency range of operation is high, and it has a higher broadband. I mean, the data transfer rate is very high, as well as it has low latency. Latency means it's a measure of delay. So, meaning to say that if a packet of time taken by a data packet from one destination to another destination, we can call it as latency. Basically, the ideal value of latency is close to zero because we are communicating with the machines to machine, so that the latency rate should be very very low. So this can be possible with 5G because the transmission rate is high. So these are the 5G in industrial revolutions. We have reconfigurable factories, mobile robots, and a single network. Everything will be operating in a single network. We can add more devices using 5G, and maintenance cost is low. Network security is more in 5G. So that's why we are, because now every country is moving towards 5G, shifting to 5G. So in Malaysia, many use cases, 5G use cases in various states. So this leads to Malaysia to the Industry 4.0. Not only Malaysia, the country which have moving towards 5G, they will go to the next level of smart factories. So when you design 5G, as I mentioned that the various advantages. One is a diverse services, a spectrum bands. It has various spectrum bands, and meaning to say that enhanced mobile bandwidth, as well as diverse deployments. We can deploy in various places, including indoors, macro to indoors, from macro to indoors. So, what are the features of 5G edge cloud? Okay, so because every stations we have a edge cloud environment, because previously 4G All the data will be processed at the cloud level. Now at the machine level, that we can call it as edge computing, it happens. Okay, industrial automation. As I mentioned, industrial 5G industrial automation, we have process automation and human machine interface. So the latency is 5 milliseconds. As I mentioned before, the latency is a measure of delay. So the time taken for packet from one machine to another machine is should be calculated as a latency. So here it is 5 millisecond means it's close to ideal case it's close to zero, but in real case it's 5 milliseconds with the help of implementing 5G in industries. For human machine process automation, it is 5 millisecond, and packet loss rate is as low as 1 e power minus 4. Whereas human machine interface, the rate is low as 1 millisecond. Okay. So now we understand what is 5G. 5G is for broadband services and more spectrum band, low latency. So due to this new technology, we are connecting our industries through 5G networks. Next one, before we go for IoT in the industrial Internet of Things IIoT, first we should know what is Internet of Things IoT. So in IoT, we are connecting physical objects embedded with electronics through a network. So it is a network of connection of smart devices which can communicate via internet. That we can call it as Internet of Things. IoT applied in various sectors, medical, agriculture, um, our smart cities. So one of the good thing is it penetrates nowadays in all sectors. Why? Because it allows all the objects to sense and control remotely across the existing network infrastructure. So as I mentioned that each have sensors or every object has its own unique address. Why this IoT becomes popular now? Because those days the electronics I mean capability or RAM capacity is limited. Nowadays, with the latest trend, more wireless sensors and high RAM capacity because we are handling with huge data, massive amount of data. To handle massive amount of data, recently many new processors are coming in and cloud computing, smartphone penetrations, all this leads to IoT because those days the limitation of electronics, so that's why the penetration will be less. Now, when you look at your, you can see everything in your mobile phone because since everyone is using smartphone, so that's why implementation of electronics in various vectors is possible, so that IoT comes in place. So first you should know what is IoT. What is the life cycle means? What are the phases, different phases of IoT? Actually, the data are collected. First phase is that data are collected from sensors, and these collected data are communicate through the communication protocol. And at the cloud side, the data will be analyzed. Data analysis. Sometimes it is a local server or it's a cloud servers which is outside the rented one. And finally, based on the analytical data, a feedback loop is created, so it will act. So this is the life cycle of an IoT. So the architectural element of when you implement IoT, the first is the sensors, end nodes. We can call it a sensors, microcontroller, actuators. All this in the first phase. This can be connected with the communication gateway, and then finally it sends to the cloud for data analytics. So this is the basic block diagram view of IoT, so which represents the architecture, entire architecture. So sensors, we have various sensors because nowadays the advancement in electronics, the electronics industry, they manufacture variety of sensors, temperature, humidity, motion, light, etc. As well as the actuators, motors, switches, and connectivity, communication connectivity can be possible through Wi-Fi, Ethernet, Bluetooth, and GPS and GRS and GSM. So all this technology, using this technology, we can implement IoT. So for the sensors, it are connected devices, and it goes to the communication equipment. Like Ethernet is one of the communication equipment, and then it goes to the cloud environment for data analysis. Finally, our gadgets like our tab, our smartphone, we can see the outcome display. So it is a combination of hardware and software. Okay, so when you design a industrial, now we are moving towards industrial IoT, meaning to say that the implementation of Internet of Things in industry. So what are the factors we need to consider? Because we need a dedicated network, unifying connectivity, and low latency. As I mentioned, the latency means time taken for a data packet to travel from one destination to another destination, and a reconfigurable Ethernet, industrial Ethernet, and deployment of private 5G network. So these all can be possible with the help of 5G, so that we can deploy our, or we can implement our industrial IoT with the help of our 5G network. Finally, all services have private 5G, because if we have a multinational company, they have their own licensed 5G private network, so that you have a ultra reliable low latency communication between them, time sensitivity networking, and dedicated licensed spectrum. So these are all when you design the factors when you design for an industrial IoT. Industrial IoT. Next one is the industrial Ethernet, because in any manufacturing industries, smart industries, the industrial Ethernet connects and enables IoT connectivity through Ethernet and other industrial protocols uh, in all levels of floors, from connecting different machines, sensors at the factory floor level. So basically, industrial Ethernet have penetrated into the modern digitized manufacturing sectors. It improves the network and system performance, the implementation of IoT from connectors, cables, systems, and many factors depend on this. So that industrial Ethernet has become a major role in communication in manufacturing industries. Okay, so these are all the, because as I mentioned earlier, all levels of operation from cloud to sensor at the possible, the factory level floor. So these are some examples. The PoE cable, it provides performance of CAT 6A level, and IEC standards also we can follow. So later my following slides will support these parameters. Okay, see now you see the how we can upgrade our existing industrial networks with wireless 5G. Because of I mentioned that previously we have 4G communication. All these are connected with the local area network previously. Because why? Every industry floor have its own automation, but now through connecting through the wireless can be possible with the help of 5G. So that's why Ethernet adoption, 5G and Ethernet adoption, and edge computing are in place. Because previously all this data will be sent to the cloud. Now due to edge computing, everything can be possible at the machine level itself. So this picture will depicts the how to upgrade your existing industrial network with wireless 5G. So you can see here small cells, core networks, everything modified. Previously, industrial Ethernet example is a Profinet is used. Okay, so we can upgrade we can integrate with 5G connections now. So it leads to the 5G industrial network. So this picture depicts the how a 5G industrial networks looks like. So wireless edge for industrial IoT, another one. Because of this 5G, the wireless edge computing is possible. So meaning everything will be at the industry IoT level. So we have a local network at the edge, all edges, meaning to say that RAN and core network of analytical functions, and cloud services also connected together. So edge computing plays a major role in deploying 5G in industrial IoT. So what is mean by edge? Edge refers to the computing infrastructure that exists close to the source data. Previously, actually close to the source data means close to the machine. So in edge computing, data is processed by the device itself, every device, or by local computer, rather than sending to a data center. Previously, we send the data to the data center. Now, due to the advancement of edge computing, everything can be possible at the device level. So it's store, filter, and send data to the cloud. So we have a edge gateway. Basically, the edge gateway is actually this role of computing, edge computing. I mentioned store, filter, and send data to cloud. So these connections actually internet and local edge side actually LAN and WAN connection inside. So we every the edge computing will be processed at the done at the level of the device, and then later the data will be communicated to the cloud. So we have a edge gateway for this process. So you see the here in this slide sensors and controllers. So what happened? The edge after the edge, then it will come to the controllers. Controllers will activate everything. Okay, so I mentioned the gateways. Gateway, what are the different types of industrial communication gateways? Modbus, HTTP, Profinet, Process Field Net, and message queuing, telemetry transport, MQTT. So these are the various types of industrial communication gateways. So I mentioned it's one is the Profinet. It's the industry technical standard for data communication over Ethernet. So it can collect data from the controlling equipment in industrial systems. Because in industry we have a machine as well as the controlling device, everything. So this process field gateway, this standard is used for data communication over the industrial Ethernet. We can call it as Profinet. So Profinet, how the connections from every machine, see machine 1, machine 2, and machine 3. So these machines are, the data from these machines are connected to the Ethernet as well as the Profinet. Actually, it's a two-way one. The Profinet standard is gateway is used for the communication purpose. It's used as a Ethernet as a communication medium. Actually, Profinet. So you see this all the machines connected to the Profinet gateway as well as the Ethernet also connected. So in this way, we can connect the industry standard protocol for gateway and industrial IoT. So 5G industrial IoT, so enhanced mobile broadband, automated guided vehicle, massive IoT, URLL, edge computing analytics. These are the major advancements using 5G industrial IoT. So we have a head-mounted display. The latency is less than 10 milliseconds, whereas for handheld very fast. Then sensors negative 10 100 microseconds because milliseconds, because sensors is for monitoring the process. So process monitoring should be very fast so that the latency, the delay time should be very less. And then for industrial robot for motion control, so it's also act according to according to the signal. So that's why the latency should be 1 millisecond. But a head mounted display and a handheld terminal and all, we can have a higher rate of latency because it's only for the display purpose. But the sensors, it will act immediately. Whenever any signal comes in, it has to sense us very fast and communicate to the other devices so that the industrial process can complete properly. This can be possible with the help of 5G because 5G have low latency rate compared to the 4G and other technologies. So that's why now when the 5G penetrate in industries together with IoT, we can have smart factories with digital, all digital technologies. It offers many advantages like low cost, improved work, I mean workforce. So many things are in the advantages. Okay, the 5G connectivity, as I mentioned, powerful. We have a powerful processing because those days the CPU and then other processing are very slow. But the advancement in electronics can be possible with powerful processing and computing. And another one is AI, artificial intelligence. Artificial intelligence also nowadays become popular. Why? Because of the processor. And then there is the graphical interface, and then the massive amount of data can be handled with the help of the advanced processors and the edge servicing, edge computing. So these are all the developments with the help of electronics so that the computing will be fast, very fast at the industry level. Whereas the 5G is more secure. 5G is more secure, and the connectivity of 5G in industries will improve the performance. Previously, we have a gigabit LTE, IoT. LTE means long-term evaluation. It's advancements of 4G and mesh connection, Wi-Fi and Bluetooth. But nowadays, 5G connections have improved performance in terms of I mean efficiency of the manufacturing. Okay, so I will give an example. Okay, Datanis is a company. It's a cloud-based hosted platform for Internet IoT. Okay, so it is a enterprise industrial IoT platform. Datanis. It handle big data and various factor. I mean advantages are there. So that's why we go with this data noise platform for when you want to upgrade your industries for smart industries with Industry 4.0. So then this is one of the available platform which connects all the IoT devices. Okay, now let me take an examples because now you understand what is how when you implement 5G, what is the advantages, and with the integrate with the IoT, what is the progress in industries and how we can achieve Industry 4.0 to say that automation
Right. Seems due to some technical problem, we have come to an end to the presentation. So we'd like to thank Professor Sadiq very for addressing this interesting topic, and thanks to the audience for their active participation. Hopefully, this presentation was beneficial to everyone. And on behalf of Masa, we would like to thank you for joining us today. And thank you for your time